Hello class, and welcome. Today, I will go over everything you need to know to evaluate limits. Firstly, let's begin by defining what a limit is. A limit is the value that a function approaches as the input x gets closer to a specific number. It tells us how a function behaves near a point, even if it's not defined exactly at that point. To start simple, there are three ways to evaluate limits. We can evaluate limits with graphs, tables, and we can evaluate them algebraically. Let's look at this graph. We want to know what the limit is as x approaches 2 here. To do this, we need to know the y value that the function approaches from the right and from the left. What do you think happens if the limits from the left and the right aren't equal? I will tell you. If the limits from the left and right aren't equal, the limit does not exist. In this example, the limit does exist because the value of the function, as x approaches 2 from the left and right, is the same. Let's look at an example of a limit that does not exist. This limit doesn't exist because the limits from the left and right are not the same. This is called the two-sided limit condition. Now we can also use tables to help us evaluate limits. I find that tables also help to illustrate the two-sided limit condition. Let's look at a table where the values from the left and right converge to the same number. This is an example of a limit that does exist. Now look at this other example, where the values are different from the left and right. This is an example of a limit that does not exist. Tables and graphs can help to understand these concepts visually, but as you deal with more problems, you will find that solving these problems algebraically will be much faster. Let's use the example. Limit as x approaches 2 of the function x squared plus 2. Keep in mind that this function is continuous. To evaluate this limit, all you have to do is plug in 2 and solve, so you get 6. This would not work if the function was not continuous. So, while solving algebraically might be faster sometimes, it's not always possible, and you may need to use graphs and tables. The reason for this is that you may run into roadblocks that will make it difficult to solve. For example, try to evaluate the limit as x approaches 3 of the function x squared minus 9 over x minus 3. When you evaluate this limit, you get 0 over 0. 0 over 0 is what's called an indeterminate form. This does not tell you that the limit does not exist. Rather, that you need to do more, whether that is simplifying or trying a different method. Now, there are other ways to evaluate limits that evaluate to indeterminate with derivatives, but today we will focus on things you should try first. Can you think of a way to simplify this function? You can factor the term in the numerator and cancel out the term x minus 3 in the numerator and denominator. Then try to evaluate the function again. This time we get 6. Let's look at another problem. Try to evaluate the limit as x approaches 4 of the function square root x minus 2 over x minus 4. Again, we are left with 0 over 0. Could you think of a way to simplify this function so that we can try to evaluate it again? This one is a little harder to come to by yourself, but we can multiply by the conjugate to simplify this function. Once we do that, we can evaluate the limit again, and this time we get 1/4. Now is the part of the video where I will go over some limit rules that you should memorize. When you are studying for Calc AB or Calc BC, there are many rules that you will simply have to know. To start, here are the basic trig limit rules. Basic limit. Limit as x approaches 0 of sine x over x equals 1. Reciprocal. Limit as x approaches 0 of x over sine x equals 1. Cosine limit. Limit as x approaches 0 of 1 minus cosine x over x squared equals 1/2. Sign difference, limit as x approaches 0 of sine kx over x equals k. Cyclic limits, limit as x approaches 0 of sine x minus x over x cubed equals 0. There are also rules you need to know when evaluating limits at infinity for rational functions, that is, functions that are an expression over another expression. And that wraps up everything you need to know to get started with limits. We learned how to evaluate limits using graphs, tables, and algebra, how to handle indeterminate forms, and even some essential trig and infinity rules you'll need for AP calculus. Limits are a core building block of calculus. They show up in derivatives, integrals, and just about everything else you'll learn next. So make sure you're comfortable with these techniques and keep practicing. If you found this helpful, give it a like, drop a comment if you have questions, and make sure to subscribe so you don't miss the next topic. Thanks for watching, and I'll see you in the next one.